class this morning. Once again, we are starting with our grade 7 mathematics lesson. And of course, this is the fourth lesson of the week where we will carry on with patterns. And of course, the next step or the introduction this morning is I'm giving you the table, which consists of the X and Y values. And of course, what I want us to do in this table is to find the general rule, which will be applicable in all the sequences, starting with the X and Y values. So today, I want the rule to be in the form of X and Y. So you can see that in our table here, we have X values and Y values. So the X values here are 0, 1, 2, right up to 50, followed by the Y values, which also move from 0 to 200. Now, in determining the rule, the most important thing is to look at the constant difference, especially in the Y sector here. If you can check all the pattern there in the Y category, you should be able to find the constant difference. And of course, the constant difference in this case will be 4, because if you subtract 0 from 4, you would definitely get 4. Again, if you subtract 4 from 8, you get 4. And then 12 minus 8 will also give you 4. So the constant difference in this case will be 4, and that is the starting point. It's very important that we realize the importance of finding the constant difference. So the constant difference in this case will be 4. And then we will have to use the 4 and multiply that with the input values. Remember that in this case, the X values represent the input values and the Y values represent the output. So you simply have to multiply now 4, and you multiply that by the input value. And of course, in this case, if you multiply 4 by 0, you will get a 0, meaning that you don't have to really add anything to get to 0. Again, if you multiply 4 by 1, you'll get 4. Therefore, your Y value there will be 4. So we are going to carry on to demonstrate that what is important is that once you have your constant difference, which is in the Y values, which we have found to be 4, you can then use it to find the rule in terms of X and Y. The first point here is that you can see that we have set 4 minus 0 to get 4, and this 4 is the second term of the Y values, and 0 is the first term. So you subtract the first term from the second term to get the constant difference. Again, 8 was the third term, and then 4 is the second. So you do the same, you subtract the second term from the third. So in other words, you always subtract the previous term from the next term in order to get to your constant difference. The last one will be 12 minus 8, which is 4. So 12 again is the fourth term in our sequence, and 8 is the third term. So 12 minus 8 gives you 4. So just the rule that we are looking for, you can tell that if you look at the other different categories there, you have 5 and 20. And then from there, you've got 21 and 84, and then 50 and 200. So 50 is the input, and then 200 is the output. Now, remember that the rule can help us to find the next terms. So in this case, once we have found the constant difference, and I hope that I'm not fast, once you have found the constant difference to be 4, Therefore, the rule is you have to now multiply the constant difference with the input value, and you add nothing. So you don't add anything. The reason being, if you multiply 4, example, if you multiply 4 by 0, 0 being the first term of the input values, then you get 0. So the rule will be y is equal to 4x, meaning that you multiply 4 by the input. So if I can take you back to the table again, you can see that our x value is 0 there. So since the constant difference is 4, then if you multiply 4 by 0, you get 0. So the y will be 0 there. If you multiply 4 by 1, you get 4. So therefore, y will be 4. If you multiply 4 by 2, you get 8. So therefore, y will be 8. So again, if you multiply 4 by 3, you will get 12. So 4 times 3 is 12. And then if you multiply 4 by 4, you get 16. If you multiply 4 by 5, you'll get 20. Then if you multiply 4 by 21, it will give you the answer there, 84. And the last one, if you multiply 4 by 50, you'll definitely get 200. So you can see that it means multiplying the input by 4, that is the correct value. So 4 is the correct constant value which you can use to multiply the input values. So if, for instance, I said to you the input value is 100, then you should be able to tell that the output value will be 400, because if you multiply 4 by 100, you will definitely get 400. And the list goes. If you multiply, or if you have to now multiply 1,000 by 4, for instance, then it means your output value will be 4,000, because you also have to multiply by 4. So you multiply the input value by 4. And then again, this brings us to the rule which we have calculated as y is equal to 4x. So in other words, you can substitute any value of x in this equation, and then you will be able to get the correct value or corresponding value of y. So if 4 is 17, for instance, if x is 17, then you have to multiply 17 by 4, and then of course that will give you 68. So this goes for any value of the x value there. And then of course, the next one is to look at the next table. So I'm just gonna give you the second table, which we are now going to look at. And of course, we also have to use the example, but the example that we have just done now. You will be able to get another example. So I'm taking you now to the example, which we define as follows. We have another table here. As you can see, we have the value there, or the x values and the y values. So I hope that you can see all the values. I've tried to make my numbers to be more bold. I hope that they are all visible. Right, if you look at the table, we have x values again, followed by y values. So as I said initially, we call the x values the input values, and the y values are the output values. Remember that when we look at the two values, x and y values, the x values are also known as the independent values, because you can just select them randomly, but the y values will be called dependent values, meaning that the value of y depends on the value of x. Just as we have done with this rule here, as you can see, y is equal to 4x. So in other words, the x values are independent, but all the y values will be dependent values. In other words, they depend on the values of x. So in other words, like in this example here, if x, for instance, is 1, then the value of y depends on that 1. So it means you have to now multiply the 1 by 4 to get 4. So meaning that the value of y will be 4 if and only if x is 1. But if you were to change your x value and make it 2, then the y value will also change because it depends on the value of x. So if x is 2, then the y value will be 4 times 2, which is 8. So you can see that the value of y depends largely on the value of x. So we are now proceeding with the next table. Remember, this was just to show you how to find the constant difference. And in this case, we have found the constant difference using the sequences in y, all the y values. Now, I want you to do the same with this table here. In this table, we need to find the rule. Now we are given the x values. We are also given the y values. So now let us carry on to find the next values there, and in terms of the constant difference. So in this case, we just have to look at the constant difference, and the constant difference in this case will be determined by the y values. Now, you can see that the first y value there is 7, which then is followed by 8, and then 9, 10, right up to 17. So what will be the constant difference in this case, in the y value? So once again, you'll be able to find the constant difference. I can see that Huapele has already found the x and y value. She says that x and y values are 10. Right, Huapele, I'm sure that what we need now is just to find the constant difference. Let's rather look at the constant difference first. And we know that once you have the constant difference, it will definitely help you to find the rule. So I can see that Huapele Lehumo has just commented on the group chat to say that the x and y value is 10. Right, let's test what you have just said, Huapele. In the y values, what will be the constant difference then? In other words, the previous term here is 7 and the next term is 8. So what is the difference between 7 and 8? You can tell that the difference between 7 and 8 is 1, because 8 minus 7 is 1. Again, the difference between 8 and 9 is also 1. And the difference between 9 and 10 is also 1, because 10 minus 9 is 1, and 11 minus 10 is also 1. 12 minus 11 is also 1. And then you can see that instead of 6 here, we've skipped 6 in the x values, and we've proceeded to 7. So meaning that there's probably a value before 12, which will be 13. So you can see that there's a sequence 7, 8, 9, 10, 11, 12. And so there should be 13 in between, which we deliberately did not put. So in order to find the constant difference, you'll say 14 minus 13. So once more, as we have done with the previous one, you can be able to see that the constant difference in y values is 1, because 8 minus 7 gives us 1, and 9 minus 8 also gives 1, and 10 minus 9 is 1. Remember, these are the values of y, and we are looking at that pattern just to check whether there's a constant difference. And indeed, we have discovered that the constant difference is 1. Therefore, the rule always, you have to now multiply the constant difference with the input value and add or subtract a number. So let's start with the first one. You can see that in the table here, if I can just take you back, the first value of x there was 0. So in order to find the corresponding output number, you multiply 0 by the constant difference. And we said that the constant difference is 1. So we're going to multiply 1 by 0. And if you multiply 1 by 0, you get a 0. And to get to the output, you simply add 7. So 0 plus 7 will give you 7. The same goes for the second term there. If you multiply 1 by 0, again, you get a 1. So, excuse me, if you multiply 1 by 1, not 1 by 0, remember that our constant difference is 1. So you'll multiply 1 by 1 here, you'll get 1. And to get to 8, you need to plus a 7 or just add 7. And then you proceed to the next one. Our constant difference once again is 1. And then if you multiply 1 by 2, you will get 2. And to get to 9, you simply need to add 7. The third one as well, we have 3 there, and the constant difference is 1. So if you multiply 3 by 1, you get 3. And then to get to 10, you have to plus 7. I hope that it makes sense. I'm doing it systematically so that you can be able to follow, so that everyone can be able to tell how did we find the rule. So again, the next term there in the x values, the next term is 4. If you multiply 4 by the constant difference of 1, you get 4. So 4 times 1 is 4. And to get to 11, which is now the output, it means you add 7. You do the same with 5. 5 times 1 is 5, and 5 plus 7 is 12. And then the next one is 7. 7 times 1 is also 7. If you add 7 to that, you get 14. And then followed by 10. If you multiply 10 by 1, you get 10. And then plus 7 is 17. So the corresponding y value there will be 17. So now that you have seen that the rule works in all the terms of our table, then it means you can be able to conclude that since you multiply the rule, the constant difference by the input and add 7, therefore, remember that the input value is x and the output is y. Therefore, this tells us that y is equal to 1 multiplied by x, which is x, and then you add 7. Remember all the time that we, in mathematics, we don't write the coefficient of x if it is 1. But we know it is there all the time. All that we write is x. So we write y is equal to x plus 7, but we know that the coefficient of x is 1. Hence our constant difference is also 1. And I hope these are two similar examples, example 1 and 2, where the main purpose is to find the constant difference and use it to find the rule. So the ultimate objective is to find the rule. Now this rule, y is equal to x plus 7, applies across the board. In other words, for any value of x, you should be able to use the rule to find the corresponding y value. So as I said, when I started the lesson, I said that the Y value is dependent on the X values, but the X value does not depend on the Y value. So the X value can be independent, meaning that you can pick and choose any values of X, and then you can find, or you can use those values to find the Y values. Right? That was the second example. And then the third one, of course, we are now going to look at the table here, which is a bit different from the previous two, in a sense that our constant difference is definitely going to be different. It will be distinct. You will see that in the first category there, you are given the X values and then the Y values. Now, who can tell me now, when you look at the pattern in the Y values there, or in the output values, what is the constant difference? Just without any waste of time, or just by inspection, can you tell what the constant difference is? I see that Junior says you skip one. Junior, I see your answer. You are saying they skip one. Remember, the sequence, or rather the pattern for output values, it's 7, 9, 11, 13, 15, and so on. So what I want you to test is to check that if you move from 7 to 9, is there any number that you have to add? The same goes for if you're moving from 9 to the next term, which is 11. Exactly, Junior found that correct. You plus 2. So meaning that the constant difference in our case is 2. And how do we find that? You can either say you plus 2, or 9 minus 7 is 2. So that's how we call it the constant difference, because you subtract the previous term from the next term. Now, can we use the constant difference? Remember, I said in the previous two examples that once you have the constant difference, you can use it to find the rule. Can someone tell me how are we going to use the constant difference to find the rule in this case? How are we going to find the rule? What do you do now that you have the constant difference? How are you going to use it to find the rule? I've already explained this before, but if there's anyone who wants to chip in to inform me, how do we use the constant value there to find the rule? Once more, I'll just repeat that. The best way to use the constant difference to find the rule is that you need to multiply your constant value with the input values. In other words, the X values there. So the first value of X is 0 there. That is the first one. Now, if you take your constant difference, which is 2, according to Junior, you multiply 2 by 0, and then you'll get 0. And of course, to get to 7, it means you plus 7. So I can see Junior has already answered it on the group chat. He says 0 times 2 plus 7. Exactly, Junior, that's the correct one. So you multiply 0 by 2 to get 0, and then you plus 7 to get to 7. Remember, 0 is the first input value, and if you multiply that by 2, you will definitely get 0. And then if you add 7, then it will give you, or it will take you to the output value, which is 7. And you do the same with the second one, which is 1 there, the input value of X, which is 1. And then you are going to multiply that by the constant difference, which is 2. So remember that 1 times 2 is 2. And in order to find the output value, what do you add to 2? You add 7, so it will be plus 7. And then you do the same with the next one there, which is 2. Remember that the constant difference is 2. So if you multiply 2 by 2, you get 4. And once you have 4 here, you can tell that to get to 11, you simply need to add 7 there, because 4 plus 7 gives you 11. And then 3 is the next term. You multiply that by 2. 3 times 2 is 6. And 6 plus 7 is 13. So what is the logic of using this particular constant difference to multiply all the input values? The reason is you have to test whether your constant difference is the correct value to be used in order to find the rule. So hence, up to so far, we've tested that, and up to this term here, term 3. In fact, 3, which is the input value, we've been able to see that if you multiply 3 by 2, which is the constant difference, you get 6. And then, of course, 6 plus 7 gives you 13. Even 4, which is the next term, 4 times 2 is 8. And then if you add 7, you get 15. 5 times 2 is 10, plus 7 is 17. 7 times 2 is 14. And then, of course, if you add 7, you'll get 21. And the last one is 10 times 2. 10 times 2 is 20. And if you add 7 there, you will definitely get 27. So I hope we have exhausted the rule as far as the constant difference is concerned. So now, to find the constant difference, we have done that. We have been able to demonstrate that in the y values or the y patterns, you simply subtract the previous term from the next term. Therefore, once you have multiplied that, you add 7. That is something that we've also demonstrated. So the rule in terms of x and y will be, remember, y is the output and x is the input. So y will be equal to 2x plus 7. Why 2x plus 7? Because 2 is the constant difference. And in this case, we write it. So you can start writing your coefficient as long as it is bigger or less than 1. Then you write it there. You need to demonstrate. If it's -1, you just put a minus sign, because we don't really have to write the 1. So you don't write 1x. You simply know that it exists, it is there. So, but if it is 2, then you have to write it down. So the rule in this case will be y is equal to 2x plus 7. So that is the last point there that I wanted to demonstrate. So I hope that this lesson has shown you a bit of a way in which you can find the rule in the form of x and y. In other words, in the form of an equation. So I'm not going to waste time. I'm going to zoom directly now into the next pattern, which is different from the 3 examples that we have done up to so far. In this pattern here, all that I want you to do is to use the toothpicks or matches to make a pattern. So I hope that you can see the pattern that I've made here. The first one, you just simply take your matches or toothpicks, and then you put them together in such a way that you can have a pattern. The first one, you can see that if you count the number of matches or toothpicks that you are going to use here in the first category there, or the first 2 blocks there, you'll see that there are about 7. Because if you add the 3 at the top and 3 at the bottom, and then they are divided by just 1 toothpick there, you can see that we have about 7 of those. So you will also see the next one here, and then you can always count how many are those, and then followed by the third one and the fourth one. So in order to demonstrate the number of patterns, what I've done is that I've said that this one here will be the first diagram which we have drawn out of toothpicks, and the second one here, the third and the fourth. So that is what I've done. So you'll see that in the next table, I've been able to show you that the pattern number. So we have got about 1, 2, 3, up to infinity. So the first diagram, so that's diagram number 1, the number of matches there or toothpicks are 7. This is what I'm giving you. So I'm giving you about 7 of those. And if you want to know, how do we know that there are 7? You can simply count them. You can count them. So it's 1, 2, 3, 4, 5, 6, 7. So there are 7. And then you need to now go to the next one. So in diagram 1, as you can see, or in pattern 1, we've got about 7 matches. Those are the sticks, or rather the toothpicks. So we've got 7 of those. Now I want you to calculate in diagram 2 and tell me how many matches do you have in diagram 2, or how many toothpicks are there. Here's the diagram, I'm bringing it back to you. In this case, I just want you to check and tell me how many toothpicks are there. How many toothpicks are there in the second diagram? I just want you to read them. I'll just give you about 30 seconds just to tell me how many are there. You can start with the inside ones and then the outside ones as well. All right, I see an answer there coming from Junior. Junior says there are 14. How do you know there are 14, Junior? Junior, can you tell me how do you know it's 14? Junior, are you still there? How do you know it's 14? Because I want you to just check thoroughly. Can you see? All right, I'm glad that you can see that there's an error there. If you can just redo your calculation, you'll see that it is not 14. The inside ones, you can see that if this is a box or if this is a rectangle, then you can see that those that form a cross, there are about 4 of those. So you've got 4 inside the box. And then outside, you can see that you can calculate 1, 2, 3, 4, 5, 6, 7, 8. So there are about 8 outside. So there's 8, 2 on the sides, or 4 rather, and then 4 at the top. So there are 12, yes. And so it will be 12. So in other words, that will be 12. And then of course, this can actually go a long way. Now, you can see that in the number pattern here, or in the pattern number for X, where there is 2, the second box there, it means you are going to write 12. So the number of matches, or rather toothpicks in the second box, or the second diagram rather, will be 12. But in the first one, there are 7. Now, I want you to check the third one and tell me how many are they in the third one. If you can just calculate this box here, or this diagram, how many toothpicks are there? How many are they? Remember, again, you can just check those that are inside, and I can quickly see that those that are inside the box will be about 7 of those. So those that are inside are 7, and the outside ones, the top is 3, the bottom is 3. So that's 6. And then the side ones, we have got 2 times 2, which is 4. So all that you need to do is now to add 6 plus 4, which is 10, and then plus 7 is 17. So you can see that we have got about 17. Yes, Junior also got 17. So we've got about 17 toothpicks now. Now, once you have 17, you can be able to go to your table, and then you can put the 17 next to 3, meaning that the corresponding value there will be 17. Now that you have done the first 3, you don't have to calculate or count all of those. You can actually count. I'm talking about the 4th diagram. You can still count, but now you can see that we already have a pattern. And what is our pattern? The pattern will be 7, 12, 17. So that is our pattern in the number of matches. So you can see that in our pattern, the constant difference will be 5, because 12 minus 7 gives you 5, and 17 minus 12 also gives you 5. So we already have the constant difference, meaning that, excuse me, for you to get to the next table, for you to know the 4th table there, how many sticks or how many toothpicks or matches are there. For you to get that, it means you simply need to add 5 to 17. And of course, 17 plus 5 is 22. So if you count the next toothpicks there, you'll see that the total number is 22. So this actually demonstrates that you now have a pattern which you can use to find the next values. And of course, in the 4th one there, it means you will now have 22. So your sequence is there. And remember, if you now want to find how many sticks will there be in the 10th diagram, how are you going to find it? Then you need to now use the constant difference, which I've shown you. In this case, the constant difference is 5. So it means you are going to multiply 5 by 10. All right. So, but before you get there, you can start by multiplying 5 by 1, because the first term is 1, the first pattern in the x values there. If you multiply 5 by 1, you get 5. And then to get to 7, it means you plus 2. So therefore, your rule will be y is equal to 5x plus 2, because you multiply the input by 5 and then you add 2. So in order to get the last one, or the 10th diagram, you are going to take 5 and then you multiply it by 10, which will give you 50, and then you add 2. So therefore, there will be 52 toothpicks in the 10th diagram. The number of toothpicks in the 10th diagram will be 52. And I hope that this lesson has demonstrated our capacity to find even the biggest numbers just by using the constant difference. And I hope that it will help you a great deal. Let me take this opportunity to also ensure that I take you back to the pattern below. And then, of course, you can see that this is a pattern that has got a position and a term. And of course, you can just find the missing values there, just to find the missing values which are not in the table. This actually brings us to the end of our lesson. And of course, this lesson is brought to you by the STEM Digital School in partnership with the Sasol Foundation. And of course, if you have any further questions, please feel free at any time to send an email to STEM Digital School at africateamgeeks.co.za. Just to go back to the chat group, so that it looks like we have another. All right, so it's Huapili who's also saying thanks, Junior as well saying bye. So thank you very much indeed, good people. Until we meet tomorrow, thank you, take care of yourselves.